Alright, so this video is going to be real short and sweet, which is probably good news for most of us. So, in video 9.3, we're talking about how to find a horizontal asymptote mathematically. So, in the intro video, or the introduction I did in class, if you were here, we just looked at the graph to find a horizontal asymptote. But even if we don't have a graph, we can find this fairly quickly. So here's notes I would write down, just to have for the future. The degree. If you remember, the degree of a polynomial is the highest exponent. So if we have like x to the fourth plus x cubed plus x plus 3, or something like that, the degree would be 4. So the degree is the highest exponent. So when we're doing horizontal asymptote, we're concerned with what is the degree of the polynomial. So look at the degree, and if the degree in the numerator equals the degree of the denominator, so if we have like x to the fifth over x to the fifth, so if they both have a degree of 5, we're going to divide the coefficients of that largest variable, or largest exponent, sorry. If the degree of the numerator is greater than the degree of the denominator, so if we have like x to the fifth over x squared, 5 is bigger than 2, so the degree of the numerator is larger. So if that happens, there will be no horizontal asymptote. If the degree of the numerator is less, so if we had like x squared over x to the fifth, where the numerator is less than the denominator, then we have an asymptote at y equals 0, which is kind of like the parent function. I would pause it, and I would write these down, and I'd put this somewhere safe. Okay, there's 4 examples because this is not going to take very long. So we need to look at the degree. So, the degree of numerator is 1. It's x to the first. So the degree of the numerator is 1. The degree of the denominator is x squared, so the degree of the denominator is 2. So if the degree of the numerator, so the numerator is less than denominator, and we hopefully just wrote these notes down because I'm not going to go back. So if the numerator is less than the denominator, then we have a horizontal asymptote at y equals 0. And this is our horizontal asymptote, if we didn't write that down either. So if the degree of the numerator is less than the denominator, boom, y equals 0. If we look at the second example, the degree of the numerator is 2. The degree of the denominator, it's x and x. So if we distributed this out, which we don't actually have to do, x times x is going to give me x squared. So since x times x gives me x squared, the degree of the denominator is also 2. Don't be fooled and think the degree is 1. They're being multiplied together, so we know the degree is 2. And if we remember back from the notes we hopefully just wrote down, if the degree of the numerator is equal or the same as the degree of the denominator, we divide the coefficients. So the coefficient is 5, and there isn't 1, so 1. So we divide the coefficients, which is 5. So we have y equals 5. So my horizontal asymptote is y equals 5. And the reason I divided by 1 is there is no coefficient like a 3, 4, 5, something like that in the denominator, so it's an assumed 1, because if we multiply something by 1, nothing changes. The third example, the degree of the numerator is 3, because it's x cubed. The degree of the denominator is 2 because it's x squared. If the degree of the numerator is greater than the degree of the denominator, we have no horizontal asymptote. And again, that's based off the note. That's a rule. If you graph it, you'd see that there just isn't one. So our last one, we have x, x, x. So the degree of the numerator is 3, because we don't actually have to distribute, but we'll kind of fake distribute. And if we did distribute, we would get x to the third. So the degree of the numerator is 3. The degree of the denominator is also 3. And if the degrees are the same, we divide the coefficients. So the coefficient of the numerator is 3. The coefficient of the denominator is 2. So my horizontal asymptote is going to happen at 3 over 2, which is just 1.5 if you're a decimal person. So finding horizontal asymptotes, you find the degree of the numerator, the degree of the denominator, and then you just have to figure out which of the 3 categories it falls in.